ABC Engineering employs a large number of engineers. A researcher wants to know whether the salaries of these engineers are related to their education and experience. She has obtained data for a sample of 20 engineers on their yearly salary, their undergrad GPA, and their number of years of experience. 4 computer outputs are given below. Choose the correct outputs to answer the following questions. So, according to the problem statement, salary is related to education and experience. Education and experience are two factors affecting salary. Therefore, salary is the dependent variable y and sample of 20 engineers. Sample size n is 20. For each of 20 engineers, they recorded salary, education, and experience. How did they measure salary? Usually dollars, and their undergrad GPA 3.5, 4, and 2.5 like this. Their year experience 1 year, 2 years. Therefore, ratio level, breakpoint average is interval level. And 4 computer outputs are given below. 4 outputs are given below. You have to choose the correct output. So y is salary, x1 predictor 1 is education, experience, years of experience. Second predictor x2. Now check here you see regression and yellow. Regression, degrees of freedom 1. Here the number shows the number of predictors. So in this output is for the regression model with 1 predictor. So not for us. And second one, number of observations 20, n is 20, correct. x1, x2, 2 predictors, correct. And here experience dependent variable, correct. Salary, salary is y mustn't be here, false. Therefore, not this output. A3, n is 20, correct. Here degrees of freedom 2, x1, x2, correct. And here yearly salary, y is here, false. The 2 must be only x1, x2, not y, so not this one. And here dependent variable salary, correct. N is 20, correct. Degrees of freedom x1, x2, correct. And here undergrad GPA x1, first predictor, correct. Years of experience, second predictor, correct. So among the 4, this is the output for us. You choose like this. Now the regression model is y hat. Y hat estimated y is equal to alpha plus beta 1 x1 plus beta 2 x2 plus and so on. Beta k is k. K is the number of predictors. This is the model for the population, the best fitting model for the population. If we could measure all data of the whole population, we could have constructed this equation exactly. But we didn't have all data for the population, therefore we collected the data for only a sample, and mathematics can find the best fitting equation of this type for the sample, the best fitting for the sample, and we have to use only this equation for the whole population. Okay, the equation for the sample given by the sample data is y hat is equal to a plus b1 x1 plus B2 H2 plus and so on, BK HK. We know the values of A, B1, B2 to BK exactly. Okay. Now let's see our output and identify A, B1, B2, B3. Okay, here intercept, this is y-intercept. A is 4012.80219. After x1 is here, undergrad GPA, B1 is here, 18,189. And years of experience x2, B2 is here 2,538.87237. Now you know their values, the value of A, B1, B2. Now question number one, predict the yearly salary. Why? We have to predict, estimate the Y. Who has a 3.5 undergrad GPA? X1 is 3.5 and 10 years of experience. X2 value is 10. Okay, we have to enter in this equation A. We know the value of A, we know the value of x1. Now we know the value of b1, and x1 is 3.5. we know the value of b2. You pick up the value of b2 from the table and multiply with 10. If you compute like this, you will get the salary, estimated salary, and you will get to the nearest dollar $93,063. Second question, interpret the coefficient of determination R square. So recall that the interpretation of R square is that the regression model explains 100 R square percent of the variation in Y. Okay, 100 R square percent of the regression model explains 100 R square percent of variation in Y. Okay, so what is the value of R square? R square is given here, R square 0.8378. If you change to percentage form, multiply by 183.78%. Therefore, interpretation is the regression model or the regression equation explains 83.78% of the total variation in Y. Y is in yearly salary. Question number 3, at 5% level of significance, that's a hypothesis to determine whether the regression model is significant. Okay, what does this mean? That means the regression equation is not trivial or useful. Okay, that means if you know the values of x1 and x2, you can predict the value of y. If you change the value of x2 and x1 and x2, then the predicted value of y will change like this. Okay, what does this mean statistically? Okay, the process of this test is here. This is called the global test of significance of the regression model. The regression model is not significant, HO, or not useful if all beta 1 to beta k are 0. If all beta 1 to beta k are 0, y hat is equal to alpha, fixed prediction only. This equation does not show any contribution of x1 to xk. This equation is in effect only the fixed prediction. Y hat is alpha, therefore useless. XA, not all are 0. Okay, some slope some slopes beta 1 to beta k are not 0. Okay, if at least one is not 0, then the equation is something, yeah, no more trivial. Okay, keep this. The process is you write HOHA like this. Critical value reading, degrees of freedom for numerator k. K is number of predictors 1 to k. Okay, degrees of freedom for denominator is n minus k minus 1. N is the number of observations, sample size. K is the number of independent variables. 1 is the dependent variable y, like this. F table, F graph. F graph is always positive. The table you read is right tail table. The rejection region is on the right. Okay, test statistics here in the output. Okay, if the test statistics is in the rejection region, then you reject HO. Okay, like this. Okay, note this process. Then you can write 3. At 5% level of significance, that's a hypothesis to determine whether the regression model is significant. Okay, our equation has 2x1 x2, therefore beta 1 beta 2 0. Okay, HO beta 1 not 0 or beta 2 not 0 or both not 0, like this. Yeah, you can write also like this. After the critical value reading, okay, what is the F table? Degrees of freedom for numerator 2, yeah, x1 x2. Degrees of freedom for denominator n minus k minus 1. N is 20. 20 minus 2 minus 1, 17. Yeah. Degrees of freedom for numerator 2, x1 x2. Degrees of freedom for denominator n minus k minus 1. 20 minus 2 minus 1, 17. So 3.59. On the right of 3.59 is the rejection region. Now you see the critical value is positive 3.59. Okay, 3.59. What is the value of the statistic 43.92? You have to pick it up from the ANOVA table. F value, right? 43.92. Okay, 43.92. This is the F statistic. The statistic, its p value is smaller than 0.0001. Very, very small. Okay, therefore, the statistic and p-value, if you say precisely, p-value is smaller than 0.0001. Very, very small. P-value is smaller than alpha. Alpha is 5% level, 0.05. Therefore, reject HO. So you write the conclusion would be that the regression model is significant. Significant means HA. Okay, finish. Question 4. At 5% level of significance, alpha 0.05, that's a hypothesis to determine whether GPA is a significant X1, yeah? Significant explanatory variable. X1 can explain the values of Y. This is the meaning. Significant means it has effect. Yeah? X1 affects Y. X1, yeah, so you study this test. So this test is called the individual test of significance. So our equation is y hat is equal to alpha plus beta 1 x1 plus beta 2 x2 for the population. Beta x1 is GPA. You say that x1 has effect upon y if beta 1 is not 0. If beta 1 is 0, x1 has no effect upon y. Therefore, HO beta 1 0, HA not O, HA beta 1 not 0. Okay. And for this test, you have to use T distribution with degrees of freedom n minus k minus 1. N is sample size, number of observations. K is number of predictors. And After computing test statistics, here are rejection regions, critical value reading. Critical value reading is here is this one, yeah. T table m minus k minus 1. Okay, then you get critical values, and the red areas are rejection regions if the test statistic formula is this way. If you test x1, this is beta 1, then b1 divided by sp1. You can pick up b1 and sp1 from the outputs. Then how to decide the right conclusion. Now you study question and answer of 4. Here, not H. This is GPA, right? GPA. Okay. GPA is X1. Therefore, beta 1 0, X1 has no effect upon Y. Beta 1 not 0, X1 has effect upon Y. Critical value reading. Let's read it. And how to find test statistic, p-value. Yeah, you can pick up test statistic and p-value from the table. Let's see. Okay, our test is beta 1 0 or not 0. Two-tailed test, alpha 0.05, 5% level significant, therefore this column. And degrees of freedom m minus k minus 1. N is 20, k is number of variables, predictors 1, so 17. Row 17. Therefore, you get 2.110. Two-tailed test, therefore, plus and minus 2.110 two critical values. You get now the critical value confirmed. Now, test statistic, T statistic, this column, and GPA, testing GPA, therefore 4.53. 4.53. Test statistic p-value is 0.0003. Now the test statistic and critical values are confirmed. The critical value, if you test statistic is in the rejection region, farther from 0 than 2.110, therefore reject HO, or p-value is more than alpha by 0.05, therefore reject HO. So you write like this. Question number 5. Which independent variable is R significant at 5% level? So we have tested X1. Tested X1. GPA. GPA is significant, right? Significant. GPA is significant. Okay, how about years of experience? X2. So beta 2 0 or not? Critical value is the same degrees of freedom. Test statistic, let's check test statistics and p-values. For X2, P2, SP2, T statistic, p-value. P-value is 0.0004, smaller than alpha by 0.05. Reject HO and the same.